ALR class. It's great to see you again. Today we'll discuss the project of visualization for small open source LLM application. This project involves using fine-tuned LLM of smaller sizes, preferable 1 to 4 billion parameters, allowing us to consider training them on local PC. So continue the project we discussed last time and the presentation of the research paper. One interesting topic, personally, I still feel the amazing is the paper called Attention is All You Need. It introduced the transformer concept, which have become prevalent in today's LLM applications. The project's visualization will include a demo of what inside the LLM. Suppose we have a data set of roughly 100 to 1,000 pair of sentences, depend on hardware support. For example, here are 3 pair of sentences, such as the cat run fast, a dog jump high, and the cat sleep well. We also have sentences for the fine-tuned model, as you can see on the screen. This sentence will have similar meanings, but are rephrased with different style. This allows us to evaluate the fine-tuned model causing various evaluation phases. The first step of our demo is show you how these sentences appear inside the LLM model. We're using a tool called w09c, which can display the detail of the layer and the attention layers. We will cover this in the next few slides. This tool works closely with Python. Essentially, our visualization tool for the project research is Python-based. Python have a rich library and add-on tool that allow us to use it as an interface programming language to make individual component work. For example, we can use it for visualization of 2 sentences. This slide will further discuss first how it works with Python and how it interactive with the data and data set. So these slides talk more about the bird with and how it works with the Python and how it interactive between the data set. So as we demo in the previous slide, and this is the attention layer. It depends on how big the model. And on this, what x-axis is the attention head. And I point to the 0 layer, the second head. So it show me something like the attention weight. The stronger, the thicker the line, the heavier the weight. And on the top of this is also the interaction for each layer. And this is the 12 head. So, but it's shown in the different color, but actually the same thing, you see the same pattern. So, and if we click on 2 header, like this one, then it will show, this header and this header. Then it will show more detail, the relation between the sentences. So the attention mechanism is, it pay attention for the sentence to sentence, the sentence itself, and also the different layer for attention, the different sentences meaning. So this app gives us very detail about what's inside the famous LLM model, the attention layer. Also, as we can see, we're using the data set sentences to do the analysis. So we already hand on more detail about the visualization of the dedicated data set. So here's the project workflow. Uh, in the previous slide, we talking about the attention layer, but this is using the existing old model. As we say, we like to using some new model, the general tree. So they released about 2, 3 weeks ago, and so powerful. So that we will evaluate the fine-tune LL model to see some pair baseline sentence will change the behavior. For example, this is the baseline sentences, and this is the rephrased one. So same meaning. But as you will see, if based on the old model, existing model, without pre-train, the connection is very weak. You see here, the line is very weak. But you can see here, the line is very strong. So I expected after the fine tune, uh, the the pattern will be changed similar to this one, such as uh, uh, the connection is strong like the toe and limbs and something like that. So this will be part of the evaluation. We focus on this one, the visualization of the fine-tune model. How good is it? So before the LLM, the MLTK NLP package very popular, and I have been using before the Transformer article, and I feel the game is changing. But uh, what really changed the AI is beginning with the language itself. So that this project also we visit the MLTK package and library, and we can using that and together with something like the matplotlib and vocal sentence transformer and the other package to generate the vocal heat map and star port. Also, we by the Python interacting interface, so the user can select the word and it will display the related sentence in the baseline and the general one. So this technique can visualization can apply for the beginning phases, the data preparation to compare the data set, and also for the evaluation. So we can have a similar approach, but using the visualization with different chart for the best approach. Python have a rich library and add-on tools allow us to use it as an interface programming language to make individual components work. Personally, I have found Python's rich library very helpful because they let me integrate tools like libraries seamlessly, save me hours of coding. This has been a game changer for building our Python interactive interface, which allow users to select words and display related sentences. Additionally, Colab recently offered free AI debugging lightly within the past weeks, and I really appreciate it because it makes troubleshooting my project easier with limited resource. This allows me focus more on refining the visualization rather than stucking on error. And the shortcoming of the tool, uh, so far I feel it is the difficulty to assess the prediction rate or the output rate. So even though the echo and the transformer they offer somehow of this feature, but it's not direct access. The previous demo tool like the burst width, it cannot do this function, even they offer the transformer layer demo, tensor layer demo. So despite this, I still like to experiment if time permit. And okay, thank you very much for the meeting. See you soon.
Well, here's the good thing. This is kind of a very hot topic, so I think it's going to be it's an interesting thing to cover. I'm not saying now. I hope I'm not going to get another 19 of visualizing transformers. So that's kind of the good thing. The what I was looking for this demonstration, like I said, it was a demonstration. I want to be able to build one of these visualizations. So I didn't get a lot of information on how to build it other than the name of the packages. And like I said, maybe 10 minutes is not enough to build the whole thing, but at least start somewhere and show us how you would write the code. And by the way, if your demonstration includes code, uh, it it's okay to have it pre-written. I don't definitely you don't want to make a mistake on video and waste 30 seconds fixing something, but go over the code and explain what it does. Explain the parameters a little bit so people would understand if they have to replicate the same thing, they would understand what to look for. So, here is the color of this parameter. So that kind of gives me an opportunity to kind of cover two topics. One, like I said, I want it to be more of a demonstration. So I want to see it in action. It's more of a share screen and run it in Python. If that's for this example, it would have been Python. So run it, and you can have parts of it already run. If something takes 10 minutes to compute, have that thing done, or half an hour, have that thing done ahead of time, and then start from there. Or have the 30-minute, you can warp time and say, this actually takes 30 minutes, but we're not going to wait 30 minutes and watch something spin around on the screen. So let's jump ahead 30 minutes. This part has been completed, and now we're going to move to the next part of this demonstration. So I want to be able, it really, I think it would have been really fun to be able to have something where I can, oh no, I can now start to visualize some of these transformers and see how they link to attention. So I'm not looking for the end result. It's more like the travel. How do we arrive there? So it's not. I don't want to see, the Eiffel Tower, but I'm more interested how we fly over there, or take the boat over there, and what do I need to do to get myself over there. So that's what I'm looking for the demonstration. Again, like I told you last time, it's almost, if you almost don't need a PowerPoint for this thing. If you have it, fine, but you almost don't need it. It's more like a screen share, and here is how we are building this thing. So that's one thing I want to point out. The other thing I want to point out is, if you're using coding, again, I understand you don't want to code live. It takes too long. In 10 minutes, there's not much. You can have some code already done, but make sure you explain almost line by line and parameter by parameter what it does. So that if I want to change the color, if I want to change the size of something, if I want to look at different things on the transformer, then I know where in the code I need to focus on to make the change. Okay, for somebody who's inclined, to using coding or Python or something like that. So that's a good example that I needed to point out. Now, if it's point and click, that's a little bit easier, but even there you can make mistakes. So definitely don't want to if you made a small mistake, that's fine, fix it, and People are going to see how to fix their mistakes. But if you're using coding, just make sure it's not already built and we're just scrolling through a notebook, if it's Python, for example. And we're scrolling and it looks almost like a presentation, like a PowerPoint that's already built. Maybe change a parameter and rerun it again. No, that's another thing. Say, what if I wanted to change the size, or here is where I'm changing the size, or I'm focusing on this part of the visualization. I change this parameter here, rerun it, we see the next thing. So I am looking for a little bit of action, not a static picture, not a static notebook. Make sure you change it in your demonstration, because I want to understand how can I replicate it without having to go through the whole documentation and redo everything that you've done to build that demonstration. So it's more of a teaching moment than a final result moment. And there might not be a final result per se, but this is something we could look at, here is how we can change it. Here's what everything means, and I understand it a little bit better. So that's what I'm looking for these demonstrations. So they can be useful to get somebody a little bit faster to where they're going. What if they decide to use that visualization tool for their project, at least they have something, they spend the time in class and they understand it and they can actually apply it to their tool. So keep that in mind. I want more. I don't care as much as the final result as how do I build the final result? What other options can I have? What if you can show a little bit of changes, how those can happen? Things that are easy to change, and maybe part of disadvantages that things that are hard to change in that visualization that you're stuck with on that visualization tool. So we understand a little bit better. Again, demonstration, it's not a, that's why I changed the name. It used to call it presentation, but presentation is too static. I want action. I want to see how things get built. I want to see a building getting built rather than the final result when it's done. So hopefully that will help the next wave of demonstrations of visualization tool.